Alrighty, section 11.2 functions. So let's take a look. Make sure you get these in your vocabulary notes. Put those in there. We're going to kind of talk about this right here, this F, with parentheses and then an X, and we're going to talk about functions, and that's what they're talking about there. So we're going to get into this, and these are some things that you use quite a bit. When you get in and we're doing, and this is kind of really algebra stuff here, we're going to be doing a lot of things with what are known as functions or linear equations and so on. So there's a lot that happens with this, and these can actually tell us a lot of stuff that's very important. If I'm in a business, I can kind of figure out what my trends are by looking at a graph. Different things like that, I can figure out some things. So let's take a look at this example, and most of you probably know that when they talk about dog's life, they say that a dog's year is typically 7 human years, and so if we wanted to complete this table for the dog compared to the human, obviously the third year is going to be 21, and then 28, and then 35, and you can see that we have kind of a normal progression. We're adding in 7 to those numbers as we go down. And it says, well, how would you find it if the dog's age is 10 years old? And well, what have we done for each one of these? Looks like we multiplied by 7. So if the dog is 10, its age is 70. That is an example of a function. Pretty simple. It's not a lot to it. But a relationship where one thing, the dog's age depends on, or the human equivalent depends on the dog's age in this example. So when we have one thing that depends upon another, we call that a function. And we write the function like this. So the function of the dog's age, or the human equivalent to the dog's age, would be something like that, where we've got this function here, equal to 7 times x. And typically the way that they're going to read this, is they're going to say the function of x, or more likely you're going to hear them say f of x. So that's kind of a typical way that we talk about functions. So we'll say f of x is equal to 7x. Now the 7x is my rule. It's what I'm doing. I'm taking the value you tell me, plugging it in, taking it times 7, getting some new value. So x is my input, and I'm going to get some value out of that when it's all done. So here's a couple of examples of functions. So they say find each function value. So I'm saying if I have f of 9, if I plug 9 into my function, and here's my function, f of x equals x minus 5. And they're saying, hey, instead of x, put 9 in for x. That's what I'm doing. So if I put 9 in for x, just like I do here, I'm going to get 9 minus 5, or 4. So what I'm doing, in the last chapter we solved for x and so on. In this chapter, we're going to substitute in values and solve for another variable, or the function value, when we're all done. So here's how we would finish it. We'd say f of 9 equals 4. So if I plug in 9, I get 4. Well, let's do another one. What if I want to find f of negative 3 if f of x is equal to 2x plus 1? So I'm going to put in negative 3. I'm going to plug that in to my x and see what I come out with. So 2 times negative 3, well, that's negative 6 plus 1. Well, negative 6 plus 1 gives me negative 5. So my answer, f of negative 3, equals negative 4. All right, so take a minute, stop the tape, stop the video, work through those two problems right now. They're pretty simple, but take a minute and do those right now in your notes. Alright, so on the first one, if we plug 2 in for x, we get 2 minus 4. Well, 2 minus 4 equals negative 2. So f of 2 is negative 2. On the second one, if we plug 6 in for x, we get 2 times 6 minus 8. 12 minus 8 equals 4. So f of 6 equals 4. Not too tough. Not too bad. Alright, let's go on. Now it says you can organize the input, the rule, the output of a function into a function table. So here's an example of a function table right here. And we've got our input, we've got the rule, we've got the output. So the input value is, in most of these, it'll be x. We're going to be plugging in x. And my rule is whatever, it says f of x equals whatever that part is after that equal sign. That's going to be what that is. And then we've got f of x. So that's what my value is when I plug all those things in. So in this example, I've got this function, f of x equals x plus 5. If I put in negative 2 into here, negative 2 plus 5, negative 2 plus 5, that must be 3. Whoops, that's not quite how I'm supposed to do that. Let's try it this way. Negative 2 plus 5 equals 3. And in this one, negative 1 plus 5 equals 4. And 0 plus 5 equals 5. 1 plus 5 equals 6. And 2 plus 5 equals 7. So I just plug my values in, and that's what I get. Now, the input values, these values right here, those are known as the domain. These are the numbers that I'm putting in. What I get for output values, this is known as the range. So the way that I would write this, if somebody asked me to write the domain for this particular function that I just did, I would make a little curly brace. Hopefully it looks better than that one did. A little curly brace. And I would say, well, the domain is negative 2, negative 1, 0, 1, and 2. And if they asked me to do the range, I would do a very similar thing, make a little curly brace, and I'd write down my numbers, 3, 4, 5, 6, and 7 for the range. Now, we don't always use f of x. A lot of times we just use another variable. And typically, that variable is going to be y. So we could write this function as f of x equals x plus 5. Or we could say y equals x plus 5. Both of those are meant to represent the same thing. So let's take a look at an example kind of similar to that, and we're going to write an equation like this. We're going to use two variables. And that's the difference between what we've been doing and what we're doing now, is we now have two variables. And one variable depends on what you put in for the other variable. So let's take a look at this example. The zoo needs 1.5 tons of specially mixed elephant chow to feed its elephants each week. Write a function using two variables to represent the amount of elephant chow needed for W weeks. Alright, so just take that, if you take the words right here and you just kind of change them into the amount of chow, let's change that into a variable c. Okay? Equals, well, change that into an equal sign. 1.5 times, here's 1.5 times. Number of weeks, we'll change that into a variable called w. So there's my function. Pretty straightforward. C equals 1.5w. So now they say, hey, okay, so what if we wanted to do it for 12 weeks? Plug the number in. C equals 1.5 times 12. Well, calculate that out, and we're going to get 18. So the zoo better order 18 tons of elephant chow when it's all done. All right, let's just do just a couple more just to make sure you guys got everything figured out. So let's just do number 4 and number 6 right here. So would you do those? I want those in your notes. I want to see those. Number 4, number 6. Put those in your notes, and I'll double check those when you bring them to me to make sure you understand what you're doing.